tap it a bunch of times, it semi-works. So we'll go with that. So if you were doing the intercepts, you would cover up one term, and it would equal like 3x equals 8, and 4y equals 8. If I solve both, this one you get some decimal, 2.6 for reading, I believe. And then this one you get 2. So if you were just graphing by intercepts, that would be at 2, and in between 2 and 3, closer to 3, but not that close. So like there would be fine. And you could draw that line. Or if we solved it by slope-intercept form, it would look a little different. Eric, you have a question?
I guess when I did my slope, I was second-guessing myself because it's a negative slope.
Okay.
But obviously we don't have any negatives, so it doesn't matter for some negatives.
Yeah, it doesn't matter for your slope because let's say I started to solve this, I'd get rid of 3x. That would not work. It likes the pink, it doesn't like the blue, okay. And then I could switch these. Because I moved this over, you would end up with a negative. The only way you wouldn't end up with a negative is if it was already negative. So then if I divided everything by 4, this would give me y equals negative 3/4 x plus 2. And then if I wanted to graph that using my slope, I would still start at that same y-intercept, so you would use that regardless. But then I would be going up 3 to the left 4. My line is off. I'm going to fix that in a second. So it would look more like this. So the more accurate line for me is this blue one because it covers, it does go through the intercept still, except for that point. It definitely didn't go through that point. Anyway, it still goes through the intercepts and plots the slope points, whereas the intercepts only covers those intercepts and your line is kind of vague because we don't know exactly what the slope is. But either of those was fine. Questions there? We're going to talk about the last thing we need to do before your quiz on Friday, test on Tuesday. You guys have your review. I put that with your stuff. So after we finish our lesson for today and you guys practice, then you can be working in the review. So everyone look at the intercept notes. You should have these definitions written. I'm just going to talk through them and then we're going to actually find these. So if we were looking for the x or y intercept on a graph, that's where the graph crosses or touches or intersects either the x-axis or the y-axis. But if we're looking for it algebraically, so this is going to be similar to what we were doing with graphing, but now we're not just going to cover it up, we're going to actually do it by hand algebraically. So if we're looking for the x-intercept, the y value is 0. If we're looking for the y-intercept, the x value is 0. So they're always opposites. So that's going to be important when we go on to solve this. As we write our intercepts, write them as ordered pairs in parentheses, x comma y. You may also see different names for the x-intercepts, roots, solutions, zeros. Those are all interchangeable. They all mean the same thing, x-intercepts. Okay, questions about any of that before we dive into this? We're going to start with the graphs. And we're going to just find where does the given line cross the x-axis and where does it cross the y-axis. So look at either this or your paper. Where does this cross the x-axis? 2. So I would write that as 2, 0. Where does this cross the y-axis? negative 3. So we would write that as 0, comma, negative 8. Yes. For the y-intercept. For the x-intercept, it goes last. They're always opposites. Other questions there? What about for number 2? What are the x-intercepts? There are 2. Negative 4 is one of them, and what was the other? 2. So we would write that as negative 4, comma 0, and 2, comma 0. What about the y-intercept? So I would write that as 0, comma 8. Find the x and y intercepts for number 3. Find the x and y intercepts for number 3. Where does that cross the x and y axis? For which one? For the x-intercept or for the y-intercept? For the x, okay. 5 and negative 5. How would we write those two ordered pairs? Okay. What about the y-intercepts?
0, comma 5.
Mm-hmm.
0, comma.
Yes. Look at 4, 5, and 6. Which of those do we want to see you go over, have questions about? 6, okay. Okay, so looking at 6, where does that cross the x-axis? There are multiple. 3 and negative 5. There's one more. 0. So we would write that as, how would we write that? So 0, 0 for one of them, yep. What about for the negative 5?
Negative 5, 0.
Negative 5, 0. And then for the last one?
4, 0.
Close, round.
No, negative 1 and
Say that again.
3. Negative 1 and 3.
Negative 1 is 3. So you're talking about right here? Or where? Sorry.
On the left, 3 on top left.
Right here? Negative 1 and 2?
Yeah.
That's not an intercept because it doesn't cross this line.
3, 0.
It crosses the line, sure, but it's not. It doesn't cross that. Yes, 3, 0. So then, what's our y-intercept? 0, 0. They have the same one. That happens sometimes. Questions on this? So there's finding intercepts from a graph, which you should be able to look and find. And then we're going to do it algebraically. So there are kind of 2 parts to that. Look at the next page. I'm going to show this to you in slope-intercept form, because that's really what this is, and then I'll show you in standard form, as we were doing with the graphing, but a little bit more in depth. So the directions are on the side. If we're solving for x, we put 0 in for y. If we're solving for y, we put 0 in for x, and vice versa. So let's say we solve for y first. That would be easier. All of these f of x's, you can just change them to y. It's the same thing. So if I'm solving for y and I want to put 0 in for x, I would do that just like that. Put 0 in where x was, put parentheses around it, and simplify. 0 times 4 would give me what number? 0. And then 0 minus 8 would just be negative 8. I'm going to write that up here. But I want to write that as an ordered pair. What would that ordered pair look like? So think about what was our x value? 0. And then what is our y value? Negative 8. So if we have to solve for it and we get this as an answer, we still want that written as an ordered pair. But also, this is in slope-intercept form, so we really don't need to solve for it. You could have just looked at the very last one because that's going to be your y-intercept regardless. Questions on that before we do the x-intercept? Okay, so now it's going to get a little different. Now I'm going to solve for x and I'm going to put 0 in for y, so I'm going to rewrite this. But where y is, I'm going to put 0 instead. And I'm going to solve this for x. How would I do that? Add 8. And then divide both sides by 4. So that x equals 2. And how would I write that as an ordered pair? Close. That would be a y-intercept, so flip it. 2, comma 0. X-intercepts always start with the number. Y-intercepts always end with the number. What questions do we have so far? Let's do one more for lunch. For number 2, I'm going to again rewrite this. Y equals 2x plus 2. Without solving, what would the y-intercept be? You can look at the y-intercept of our equation to find that. 2. So I could write that as what? 0, comma 2. Just by looking at that last number. Then I could solve for x. So if I put 0 in for y and we solve for x, similar to this one, subtract the 2. And divide both sides by 2. What is that x-intercept? How would I write it? Not 2, but negative 1. And I would write that as you have any questions on that? When we come back, I want you to, well, first look at these, or when we come back, if there are any of these that you want to see to go over, we'll do that before we go on to the next thing. To see, do, or go over before we go on. So let's start with the y-intercept. The y-intercept of number 3 would be what? So we're just looking at the y-intercept. So how would I write that? If I'm looking at just that last number. Zero, seven. There you go. Okay, and then for the x-intercept, I'm gonna go ahead and instead of rewriting this, I'm going to just jump into the 0 first. So to start solving this, we would again subtract the 7. And what would I divide by? Yes.
Ms. Shepherd, could you write
Anderson of half. Do you have? Okay.
would it be -1?
So if we divided both sides, we get a positive 7. How would I write that as my order pair? Question on that one? Alright, we're gonna do number 5, and then I'm gonna show you just one of these, how you could find the intercepts by graphing on Desmos, but you'll need to be able to do this algebraically as well. So for this one, the y-intercept would be what? Do you have a pass? Oh no, that comes out. Thank you. What would that y-intercept be? I'm looking at that last number. For the x-intercept, I'm going to make this 0 equals. And we're going to solve that by subtracting 2. Then to get rid of that 1/2, instead of dividing like we have been, I don't want to divide by the fraction. I'm going to take it and flip it and multiply on both sides. So take that fraction and flip it, and then multiply that on both sides. So when I do that, the 1/2 and the 2, they cancel. This would give me -4. How would I write that as my order pair? So far, do we have any questions on how to find x or y intercepts algebraically in this format?
So for the first problem that we did, we actually had to solve for y.
So we didn't actually, I was just showing you how to do that, but because these are all in slope-intercept forms, you don't actually have to do this. Now, in the next format, we will have to solve for both x and y regardless. But, some of these are just to kind of see different intercepts. We're only dealing with linear functions, lines, so you won't see things that I'm about to graph, but just to show you what that looks like. X squared minus 16. were to type in x squared minus 16, I would get some U shape, just so you see what that kind of looks like. Again, we're not really dealing with these right now, we will later. We're dealing with mostly lines, but to find the, I think it asks for both the intercepts. Look for both the intercepts. You would just click the function. Let's make this bigger. Click the function, and then your x and y intercepts appear. Your x intercepts appear, and then you may have to scroll down, but your y intercept would also appear. Now you can put your equations in to double check what they are, but you still need to show the algebraic work if it's asking you to show your work. I didn't do this for graphing, but you can type in all your graphing equations to make sure they match as well. Okay, go on to the back of this, or the next page. Because this is the last part. I forgot, there's one other thing, but then we'll come back to that. So with this, if we're finding the x and y intercepts of these, now this is in standard form. So as what we're doing with the graphing, but we actually want to not just cover it up and solve. We want to solve like we just were, put 0 in for one, put 0 in for the other. So if I'm solving for x, I'm putting 0 in for y. This is why the cover up method worked. Okay, any computers closed? Because I put that 0 in and I multiply, I get 0. So then we could keep going. There's nothing with this, so I could just divide both sides by 8. Which is essentially what we were doing before, but not with the putting the 0 in part. So now we have to do that part. So that x equals what number? What value? On this side, but not this side. So this would be 3. And I would write that as an ordered pair, 3, 0. So if you're doing both of these, make sure you list out which ones are the x, which one are the y. If you just write the 2 ordered pairs, I don't know if you know which one it is. So 8 times 0 plus 3y equals 24. That would give me 0 plus 3y equals 24. Divide both sides by 3. So that y is what number?
What's the last thing you do?
4. So I would write that as 0, 8. You might get fractions like you started to get on the last Delta Math, the graphing. And you would just still write the ordered pair as the same thing. Leave it, if you get a fraction or a decimal, leave it as a fraction unless it's a nice decimal. I really just need to see that you put 0 in. After that, you could kind of skip steps. I'm going to show you what I'm talking about. So let's do number 2. So let's say I'm solving for x. I'm going to put 0 in, but I know that's going to be 0. I'm just going to go straight to the next part and divide both sides by 4. So that x is 2. And then I would write that as an ordered pair. 2, 0. And then if I were to do the same thing with y, I want to put the 0 in, but I know this is just going to be 0. I'm going to drop that, not rewrite it, and I know there's nothing in front of y, so it would just be y equals 8. How would I write that as an ordered pair? Yes. 6. We'll do 5 and 6, yes. Are there any others we want to see besides 5 and 6? So in example 5, this is giving you the x-intercept. You don't need to solve for it. That is it. Write it as an ordered pair.
That's simple.
Yes. But if this is an x equation, is that going to be a vertical or horizontal line? Vertical. So if I have some vertical line, I'm going to draw this. Let's say this is right here. Is this ever going to cross the y-axis?
No.
No. So I would not have a y-intercept at all. You would say none. And A doesn't exist. You would not put 0, because that would mean there was a y-intercept at 0. We don't want to write that. So then the opposite would be true for 6. The y-intercept would be given, and we would write that as 0.5, and for the x-intercept we would write
None.
Other questions that we want to see, do go over before I let you guys practice? Okay. So I need you guys working on this delta math that's due on Friday. This one is formative. For the intercepts, after you do that, you can be working on other missing delta math or work on the review that's on your desk. Or if you want to work on tests or retake work after you've done the x and y intercepts, you could do that.